Hello, and welcome, and what a great crowd. I think a tip here is if you want a lot of people to attend, mention Docker in your title. I think that's a good start. So I'm Charles, co-founder and technical architect of ThinkTilt. So what do we do? Well, we ship the same add-on to Jira Server and Cloud. Now, obviously, this is not a very common thing. Having one add-on to serve server and cloud is pretty uncommon. I'd say most vendors have a separate code base for their server plugin versus their cloud plugin. Or perhaps they simply don't support cloud at all. But we launched only late last year, and we chose a cloud-first strategy. So we decided to build a cloud add-on due to, obviously, the increasing popularity of cloud in Jira, but especially because we're focused on Jira Service Desk, which is really growing fast there. Now, here's our tiny team, the three of us. We launched at Summit 2016, and at the time we didn't have a server version. But perhaps unsurprisingly, we had a lot of people come past and say, well, where's the server version? We run server, we need server. So by the end of Summit, we were pretty convinced that we needed to have a server version by now for this Summit. But there is a problem, which is the size of the development team, which is me. So I was already going to be pretty busy. We had lots of great ideas for what we wanted to get done, new functionality, but there was no one else available to work. So, who was going to create it? It was going to be me. I couldn't bring anyone else on. I had to look at some options. The obvious option is a separate code base, and this is what I think most people do. It's straightforward. You just create a P2 plugin, you write completely new code. You might look at your other code, but keeping it separate is quite easy. But I am a tiny team, and it was going to be a lot of development time to do that, and I'm not familiar with P2 plugins very much. So I thought about it, but what really concerned me was that if I did that P2 plugin, that would only be the start of it. From then on, it would be every time we add a new feature, I'd be doing it in two places. And if I was doing it in two places, was it going to take twice as long? If it did, it could be a bit of a problem for us. We really have a lot we want to get done. I didn't want to limit the future. I didn't want to slow down the future work. So I considered sharing a library. Basically, we are running our cloud add-on is written in Scala, and Scala isn't Java, but it is a JVM language. So being a JVM language, we could theoretically package up some of our business logic, the core bits of the functionality, put it into a library, and share that same library between two of them. It seemed like a pretty good option for a while, and I started trying that, but there is a big problem with that, and that is the fact that our add-on is very UI heavy. So our add-on Proforma, it adds forms to Jira and Jira Service Desk. And forms mean, it's something like Google Forms or Wufoo built right into Jira. And that means that there's a lot of UI, and that UI has a lot of JavaScript. And a lot of that functionality just wouldn't be captured in a shared library. Now, perhaps if we'd been a little more careful and we had done the UI using velocity templates and things that were in use in Jira Server, we might have been able to share the UI, but the way we had it, we simply weren't able to. So the more I looked into this shared library idea, the more I realized it just wasn't really going to work for us. What I really wanted was a way to reuse everything we had, and I asked around. It doesn't sound like a lot of people were doing it. Some people had tried it, and they'd had mixed reactions. What I did try, though, was this single code base, and this is a quick illustration of it. We have what we call the Proforma server, and when it's connected to from Jira Cloud, we have the typical Atlassian connection to it. From a Jira server, we have a lightweight P2 plugin connecting to the same kind of server. Now, this was the idea, and if we could get this working, this would mean, hopefully, doing it a lot quicker and reducing the maintenance over time. So, That P2 plugin essentially just forwards requests to the server renders HTML and embeds it inside an iframe, very similar to the way Atlassian Connect works. And as you'll see in a moment, we did borrow a lot of things from Connect, thanks to the fact that libraries and code are available for Atlassian for reuse. Okay, so if we can get this working, what are the advantages? Well, the maintenance, there's that less effort to add new features. And hopefully meaning the ability to add features faster and keep going. The maintenance also means a smaller surface area for bugs. We do have slightly more complexity because we've got this extra connection between the two, but there's only one copy of the code, one implementation. Hopefully that keeps the number of bugs down. So feature parity. Feature parity is actually quite a big benefit. By having one code base, you guarantee that you're getting exactly the same behavior in both cloud and server. And that's not just about code, that's working on the marketing. You can sell the same story about your plugin. It's the documentation is exactly the same for both of them. And it means we don't have to have a little asterisk saying, sorry, this feature's only in cloud or this feature's only in server. It keeps it very consistent. Migration is another benefit. So we are reading and writing data into Jira in exactly the same way, or almost exactly the same way in both versions. And because of that, that means that we can guarantee that if you move from server to cloud or from cloud to server, your data is going to work in the plugin, the add-on, in the other version. That's possible in our case because we don't store data ourselves. We don't have a database with customer data. We only store data inside Jira. Finally, external pages. Now this one is more unique to us, but some people have this kind of scenario. We sometimes have a benefit to, or sometimes useful for us to serve up pages outside Jira. So we are a forms add-on. Some people were talking to us about presenting forms to the public, say on a public website, and that would be served up to an anonymous user, not logged into Jira. And on a cloud add-on, that's really easy. You're running a server, a web server. You can just direct people to that web server. It's very simple. If you're doing it within the Jira server, it's a little bit questionable. Technically, you can have a servlet which will serve up the pages to the public with no security, but it's a little bit, maybe a little uncomfortable. Using Jira as a public web server is probably not a great thing to do, and may not be what certain administrators really want. Okay. So, if we're going to have this server, really important question, where is that server going to run? We connected the P2 plugin to, if we connected our P2 plugin to an existing server, our cloud service that we run ourselves, probably a lot of customers wouldn't be too keen on that. A lot of server customers are wanting they want their data behind the firewall. They don't really like the idea of sending data off to us, some cloud provider, when they've been so careful to keep it behind the firewall before. But if we let them have our code to actually run it themselves, that's quite a big ask, asking them to run a server themselves. A lot of support for us. And it's especially tricky for a trial customer, someone who just wants to see how it works, whether it's good for them. But Docker seems to be changing that. Docker makes it a lot easier to do this kind of thing, to distribute a server, let people run it reliably. So we thought, well, if we put it in Docker, how long would it take? Don't worry, it's up. Okay, here we are. So look, I'll actually show you something. This is a computer that has Docker installed but does not have Proforma installed. So to install, well, we just type in docker run and a port number and the name of our server. That is downloading right now, and once it's downloaded, it automatically starts up our server. And there it is. So it was about 15 seconds from typing in the command, downloading our server, starting it up, and it's up and running. That's now ready to connect to our P2 plugin. So we hope that kind of speed was the difference between someone saying, oh, I'll try it out, versus looking at a long list of instructions and giving up. So, why Docker? Well, what you just saw, that simple distribution, that's really quite easy. If they've already got Docker installed, if they're comfortable with running Docker, it's just a command like that, and it's seconds to get going. Now, not everyone has Docker, but it is pretty popular. It's already used in a lot of large companies. And another important point for us is that we were considering this at Summit last year. So whenever we had someone talk to us about server, we said, well, if we provided a Docker image which contains our code, would you be able to run it? And we got a generally pretty good reception to it. We certainly didn't have everyone. There were a couple of people who said, no, we just wouldn't do it, or it's going to be too hard. I know it's going to be too hard. But I'd say the majority said they probably would, and we thought that was good enough for us. And what is also great is it helps us manage our cloud servers. So, in other words, we can do a better job of running our own equipment. And it's things like just the fact that when we started, we started running on Heroku in development, and then we turned that into production, and then we wanted to really take advantage of more powerful things like automatic failovers and load balancing and things like that. And it was a little bit hard to do on Heroku, but by putting it into Docker, it made it easy to move onto AWS, but also to do things like have a disaster recovery plan involving other providers like Azure. It makes it very easy to, I guess, professionalize and run your cloud add-on in an ideal manner. So, that P2 plugin, what is it? Well, here is a page from Proforma. So this is how it looks running inside Jira Server. And the page is rendered by a few different components. It's partly by Jira, it's partly by the P2 plugin, and partly it's from our Proforma server running in Docker. That part there, the navigation, comes from the P2 plugin. Now, we'd like the P2 plugin to be as lightweight as possible, but unfortunately we do have to configure some of the application in there. So that navigation there is configured inside the typical Atlassian plugin.xml, just like any P2 plugin. But those links are simply pointing all at one servlet that we have running inside that lightweight P2 plugin, and it is forwarding everything onto the Docker server. And that there is the page rendered by the Docker server. That's inside an iframe within the Jira page, and the page you're seeing there is exactly the same as you would see in Jira Cloud. Everything about that is the same. It's literally the same code, the same URL, the same security mechanisms. It's 100% the same. So how do we do that? Well, if you're familiar with Atlassian Connect, you would know that JWT is the way that requests are secured in Jira Cloud. We're using the same thing. The P2 plugin generates JWT requests. They are effectively signed with a secret key that we generate on installation. And it works in exactly the same way. And one of the reasons it works exactly the same way as it would in Jira Cloud is that we use the Atlassian JWT library. That library is bundled with Jira, so that you can import it with an OSGI import. You don't even have to bundle it inside your plugin. And we simply make the requests. We associate URLs with the navigation you saw there and make the requests in the same way that Jira Cloud would. The other part of this is the Atlassian Connect JavaScript. Now, it's not just the plugin talking to the Proforma server. The pages themselves talk to Jira via the Atlassian Connect JavaScript. The most common one that we use is pop-ups. Whenever we want to display a pop-up, we're making a call into the JS. Now, that library doesn't come with Jira Server. It does come, it's standard with Jira Cloud, but not with Server. Fortunately, Atlassian Connect.js library is available on Bitbucket. It is Apache licensed, which means that we can include it within our plugin. And we tried it out, and we found just dropping it in there worked almost straight away. Putting it in basically simulates what Jira Cloud does, but there is a slight catch. And so if you're familiar with the way Jira Cloud works, or the Connect framework works, you know that you include a JavaScript file called all.js. That normally lives in the root of the cloud server, in the Jira Cloud server. Now, we could effectively put it in the root or treat it as if it's in the root of Jira. But if we did that, we would be putting it there, and if anyone else tried to do that, or if Atlassian put the file in there, there could easily be conflicts, and who knows what weird behavior we'd get. So with that, we actually changed the paths, and we moved all of the Atlassian Connect library out of the root and into folders within our plugin. That works just fine, but it does mean that on the pro forma server side, we do have to change the URLs depending on whether we're talking to Jira Cloud or Jira Server. But that's a relatively simple change to make in our code. So enough of that, onto the cloud add-on, or what it became, the Docker server. So we used to call it the cloud add-on, but really, once you start doing this, it's no longer the cloud add-on, it's just your product. It is the same thing for server and cloud. So we just started calling it the Docker server. Unfortunately, it's a bit more than that. We couldn't just rename it and get it working. The REST API in Jira, unfortunately, is not the same between Jira Server and Jira Cloud. Now, depending on what you're doing, you may find the changes are minimal or they're quite large. In our case, we were lucky. The changes were very small, and we found the same APIs were there. We just got very slightly different data structures back. That became quite simple to handle. So we simply allow, we expect either data structure to come back, and so our code can handle whatever it gets. So we're not actually making any fundamental change to the calls we make to REST APIs. We just are careful to handle the data as it comes back. Another caveat, though, is that we need to use OAuth instead of using JWT. So when you're talking to Jira Cloud, you'll talk to the REST APIs using JWT. Now that's only available in Jira Cloud. JWT is not available in Jira Server. So there is fortunately an equivalent, close equivalent, which is OAuth. OAuth allows us to make calls into Jira, into the REST API, on behalf of a particular user. And that's actually remarkably similar to what happens with JWT. In a cloud add-on, when you make calls, you are making call as a user which was created for your add-on. And so that user is actually quite powerful. It's effectively like an administrator user. And then parts of the Atlassian Connect framework will reduce its permissions depending on the circumstances. So what we do is we have an administrator create the OAuth connection, and then our add-on effectively gets those administrator rights, similar to what we get in Jira Cloud. Now that's great for us because in cloud we need the administrator rights. We do make use of those, and it is part of using our add-on. But if you don't use administrator rights, if you don't need that much power, it's maybe not so good. It might be giving you more power than you want, and then you may have a more complex setup to avoid that administrator access. But in our case, how do we actually get that connection? Well, we're using application links. Application links is something you may know from connecting up Jira and Confluence. I think it's almost universally used for doing that, which is to say, when you've got multiple Atlassian applications, application links is the way that you'll make those connections. I don't see it being used a lot for things outside the Atlassian world, but it is actually possible to configure any application here that supports basic OAuth authentication. So that's what we've done here. We have a setup guide where we ask people to create that, they click that create new link, we give them some data to fill in there, generate a key for them. Once they've gone through that process, we then we send the user to an OAuth page where Jira will then ask permission for our application to do certain things, to read and to write and administer and those kind of things. Once they click agree, our OAuth token now has the ability to do all those things in the REST API. And the end result is that it behaves very much like it does in Jira Cloud. We have a very similar access level. One final thing I'm changing is licensing. So when you have a Jira Cloud add-on, you'll get calls from the Atlassian marketplace telling you about an installation, about enables, about license information. That stuff just doesn't happen in this scenario when we're connected to server, because marketplace isn't talking to our server, it doesn't know about our server. So we effectively have to move the licensing to the P2 plugin. We just have some code in there that is doing the appropriate checks and then passing on the licensing information onto our Docker server. Right, so this is onto the really exciting bit, which is how do we actually do it? How do we build and deploy this stuff? So this is an overview of the structure we have. So on the left there is the IDE. So it's me, as you know, a single developer doing this. When I make a change, I push it up into Bitbucket, into our Git repository. We have Bitbucket's pipelines running there, and pipelines is doing the build, test, Dockerization, deployments, and all of that for us. So depending on exactly the nature of the build, which I'll get into, it will then push to Docker Hub, which is a public repository. And from there, customers can download Proforma and run it. And that was that video you saw earlier, connecting to Docker Hub and installing and running there. We also have Amazon ECS with a private repository, just a Docker-compatible repository. That's where we keep our own copies, so not just the public releases, but all the development and private test builds. And from there, we deploy them onto our own cloud hosting. So that Proforma server AWS hosted is effectively our Jira Cloud. So if I go into a bit more detail about how that works, well, I push a check into Bitbucket. That's normal. You're probably familiar with that. And then we have build and test. So before we went down this route and we were running Jira Cloud, we basically had those first two steps there. The build and test runs our code. In our case, we run SBT because we're Scala, but it could be whatever you're using. It doesn't matter so much. It's step 3 where it starts to get more interesting. So there we have a Docker build. So that takes the binaries that came out of that last build and test step, and it packages them up into a Docker image. And that Docker image is completely self-contained. It contains everything you need to run. And so we have a Docker file that will define all the things we need and create that for us. Once that is built, we do a push to the Docker Hub. Now, we only push if it's needed publicly, so I'll show you that in a moment. We have the AWS push, as you saw before. And a final step, which I'll get into, is a deployment. So depending on the tagging, we may actually deploy a Docker image directly into one of our environments. And we do that without having to go through any manual steps. And I'll show you that in a moment. Okay, so here is a cut-down version of the Bitbucket's pipelines definition. It's not complete, you couldn't run it quite like this, but it has all the key elements, so I'll use it to illustrate some important things. The first part is this image that appears at the top. So that's a custom build environment we've created. But in pipelines, you can provide a Docker image of your choice that gets loaded up and inside, and then your code is copied into that build environment, and then your build is run. Now, you can use a standard generic one. You know, if you're building Java, you might get a JDK image. If you're building Node, you might get a Node image. But there is a big advantage to creating your own build image. Firstly, one of the things we've done is we've combined a few tools. So we use SBT, but we also use Node, and we have a couple of other libraries that we use in there to optimize things. By creating our own build environment, they're all there automatically. It makes it very simple to run. It's very reliable. We know exactly what's in there. There's another advantage, and it's a little trick that I think is worth noting. If you're like us and you import a lot of libraries externally, you might import Node, NPM, or you know, Maven packages. You'll find that there's a lot of your build on pipelines is just downloading those dependencies. We were having a build of sort of 8 to 10 minutes, and more than half of that, well over half of that, was just downloading the dependencies. Once we created our own build image, what we did is we would create the build image, then we would have one run, one build within the build image, and then we would delete the source code from that build image. But by doing one build, that would cause all of those dependencies to be cached within the user's folder inside the Docker image. And then we save the Docker image in that format, upload it onto Docker Hub inside a private repository. And so inside that image you see there are all our dependencies cached. That means the build is a lot faster. It cut it down to 3 to 4 minutes instead of 8 to 10 minutes. And it also means, but it's also reliable in the sense that, firstly, if something happens to those dependencies, if there's a problem in Maven repository, etc., you're not relying on that being up and running. They're already there in your image. And also, if you do change things and you forget, you change your versions and you forget to update the build image, it's still capable of going out to those repositories and finding them. Okay, probably enough on that. Let's get on to the actual build. So I was saying we use SBT. This is really 2 steps in one. SBT is capable of building a Docker image itself. So this is doing a build, a test, and creating a Docker image in one. If you're not using SBT, you'll probably have your build and test steps first, then have another step to do your Docker. Now, you'll see there this project version Bitbucket tag. This is triggered by a tag. So this is a public release build. And our convention is any tag starting with a V is for the public. And so we have v1.0.0. That's a version 1.0.0. And so that tag, that version is available in that Bitbucket tag. That tag will be applied to our Docker image so that later on, when we distribute it, the tag that we gave it in Git becomes a tag that appears on the Docker Hub. Now, take a quick aside to talk about Docker. So pipelines runs on Docker, and something that's not immediately apparent is you can't build Docker images in Docker. And it's a technical thing I won't get into, aside to say that Docker is a little bit like a virtual machine. Because of that, you can't have another virtual machine within itself. That's an oversimplification, but that's what it comes down to. So when you build a Docker image, you must have a Docker build server outside of pipeline somewhere. Now, until recently, the only way to do that is to run your own external build server. So we had a Docker build server that we were running on AWS, on a VPS, and it did nothing until a build came up, and then pipelines would connect to it and run the Docker build. I don't recommend that anymore because in the last 2 weeks, we've got a brand new option. It's called Docker True. When you add this option to your pipeline build, that will spin up a Docker build server for you. It effectively comes up in parallel to your build. And pipelines automatically configures that image to talk to it. So you don't have to do anything except just say Docker True, and it magically works. So just keep that one in mind if you're trying this. If you don't put that on, your build will fail with some obscure errors. Okay. So that last step was building the Docker image, but it doesn't go anywhere. It sits in the build environment, and as soon as the pipeline is done, the build environment will be shut down and everything would be lost. So you have to push it somewhere. And Docker Hub is, I guess, the canonical place. This is the official Docker repository. And if you're publicly distributing something, it's the ideal place. The reason is that it's the default. So you saw I typed in docker run ThinkTilt /proforma. It looked in Docker Hub to find that. So how do we do that? Well, the first thing we do, we already have the Docker build from the previous step, and it's sitting locally, and it's tagged with a version. So it'd be proforma v1.0.0, for example. But there's a convention in Docker that the latest version of your application should be tagged latest. Now, we want to do that, but we also want to have the version number so that customers can choose which one they want. Obviously, a lot of people will run older versions of Jira, and if we have an older Jira, older P2 plugin, they may want to match the older plugin to an older version of Proforma. So this tag step will add an extra tag saying that this version is the latest version. It doesn't change anything about the image itself, it just results in two tags, version 1.0 and latest. Then we do a Docker push. So Docker push with latest will copy that image up into the Docker Hub. Now, how does it know how to do it? In pipelines, you can configure environment variables, and there are some well-known environment variable names, Docker username, Docker password, that Docker will pick up automatically. So as long as you configure your Docker Hub details in there, that push will work. The final step is Docker push with the version number. Now that's very quick because it's smart enough to recognize it's the same image that you were using before, so therefore it just effectively pushes a tag up there. Once that bit of code is done, your Docker image is now available to the world. So anyone who typed in that command would now get this. You would get the latest version. There's also, if they're on the latest tag, it will cache the latest version, which means they will need to do a Docker pull and restart their Docker server to get the latest version. So it's up to them when they want to upgrade to the latest version, but they don't have to do very much other than just simply say pull the latest version, and then it's available. Okay, pushing to AWS. So I told you how we push to AWS, and the reason for that is we do need to have a private copy. What you're looking at here is a public build with a V tag, but further down, which I haven't shown you on this screen, we have a similar one which includes this, which is used for private builds. So both private and public will do this, and that is push the image to AWS. And we want to have every build on there. The reason is whenever we want to test something, we like the fact that we can have any build instantly available. So to do that, we have to log into AWS. It's got a private repository that is only available to us. So inside our custom build image, we've installed the AWS command line tools, and on the Bitbucket pipeline environment configuration, we've added some AWS secret keys to allow us to log in. That AWS command there will pull the keys out of the environment configuration and generate a Docker login command. And that tells Docker how to connect to the private repository on AWS. And we wrap it in a dollar symbol, the dollar symbol telling it that the command that comes back from AWS, we want to execute that. So the result of that first line is we are now logged in. The second line, Docker tag, well, it works just like the tag I was talking about before, but the difference with that tag is that we need to tell it about the location of our AWS repository. And again, it's another environment configuration. Finally, we do a push, and at the end of that, the image is available for use. Now, deployment. I told you how we can deploy. We have a convention where we simply have deploy dash something for an environment. So if we want to deploy to our main test environment, we tag something with deploy dash test. That will trigger this deployment script. Now we've got CloudFormation to do this. How you deploy depends on what you like to do. But the important thing to know here is that it's a really convenient way. Like if you're like us, a small organization where I guess you trust developers or people with access to Git to do the deployments, this is great. As it's really me being DevOps, it really suits me. All I have to do is sit in the IDE, decide this version is ready to go, type in, tag it, deploy dash test, push that to Bitbucket, and a few minutes later it's up and running. It's probably not great if you're a big organization and you want more control. You can, of course, in Bitbuckets have some rules about tags, but it really, this is personal choice. If you do something like this, though, there is one warning. If you tag something with 2 tags at once, pipelines will run both tags at once. So if I tagged it v1.0.0 and I tagged it deploy-prod, what would happen is I would have the build run, and then in parallel the deploy would run. But the deploy would be running before the build is finished, which is obviously no good. It would just simply fail. Fortunately, if you're a sensible developer, you're probably actually waiting for the build to complete before you deploy it. So you should really tag it, tag the version number, confirm that the build was successful, and then follow through with the deployment. But it is a slight caveat that you can't tag both at once. You have to tag one, wait, tag the other. Okay, well, now, really the question is, should you use Docker? There are a few good reasons. One good reason for doing this technique is if you have limited resources. So like I said, we really wanted to get this up and running for this summit. And we thought we could probably do this in the time available, whereas starting from scratch, we probably couldn't. So look, it's better to support server customers with something that only some can use than not support them at all. Another good reason is if you have external functionality. So if your add-on is not just a few things within Jira, but has components that live outside, especially public-facing web pages or possibly more complex functionality, long-lived functionality, things like that. Putting it in a Docker image can be a great way to make it available to people behind the firewall. And another one is the consistency, and I really think it shouldn't be underestimated. It's easy to say it doesn't really matter, but it really does make it so much easier, because it's not just easier for me, but it's easier for the rest of my team who are doing the marketing, doing the documentation. And the consistency in the data formats means that we can be confident that customers migrating from one to the other will get the same result. They can migrate, their data will be there, the add-on will keep working. But it's definitely not all perfect. There is a lot of extra complexity, complexity for the customer. So firstly, the extra steps to install the plugin really could be off-putting, and to be honest, I think there will be some customers who do find it off-putting. I didn't go into this thinking everyone will be happy with it, but the use of Docker in particular makes it a lot easier than other solutions where we expect them to run things. Now, we are considering a few improvements. Obviously, we are running the same code in the cloud, and we could get our trial customers to connect to our cloud servers. Obviously, they'd have to tick a box and say, yes, I know my data is going off to the cloud and all of that. But that would be fairly straightforward, except for one thing, which is we can be sure that we can talk to our server in the cloud, but depending on their network configuration, maybe we cannot talk from our cloud server back into theirs. And it just depends on the corporation and how they've set up their network. So for that reason, we haven't yet done it, but it's certainly something we're considering, possibly having a little check on startup so that when the P2 plugin, when you go to the configuration page, it might just do a check and say, you could trial this using our cloud server, and it will just do a two-way connection check. And if that works, allow them to do it. If that's possible, it would be easy. You could download and just run your plugin. You wouldn't have to know about Docker. It may be a good solution, but we haven't tried that yet. Lockdown networks really is a problem. This is related to what I was saying about the cloud. Even if you have everything behind the firewall, some corporate networks will tightly control their Jira server so that not much traffic can go in or out of it. It's really only through that main HTTP port. So it could be that they install a Docker server, but the two of them can't talk because the network's locked down. Obviously, IT can fix that, but maybe they're not happy to. Maybe they question it, that kind of thing. This is the kind of thing we're not sure about yet. We're going to find out as more and more people use it. And there's one other one that's come up. You've probably heard about Atlassian Design Guidelines 3, the new look that's coming to cloud products, Jira Cloud, Confluence Cloud, etc. One problem with that, I love that new look, and I'm really keen that we use that new look. One problem, though, is it's coming to cloud in the next few months, but it's not coming to cloud to server at least in the next year, and possibly much longer. So if we're probably going to have a period where we're going to be using the new look, and that code is going to be effectively pushed into server, and so server customers are going to see that. Obviously, we could have two versions of UI, but as soon as we do that, we're starting to get into the problems I was talking about with the shared library, which is to say, we've got a lot more maintenance, a lot more work, a lot more potential for bugs. So we'll see how we go. We may just give everyone a new look and hope they're happy with it. One thing to mention, though, if all of that seemed a bit too hard, like you're a little bit worried about pushing this to server customers, if you have a cloud add-on and you're not using Docker to deploy it, I think it's something it's worth considering. There's a lot of value in it. It's a lot easier to test. It's a lot easier to keep copies so that if you want to move backwards and forwards through versions, you've got a library of them, and it's very quick to deploy them and switch them out. If you have a problem, it's just 30 seconds to switch back to an old version. The other thing is it's great for disaster recovery, to deploy into different zones. So, for example, if you want to have a European version, now that there's going to be a European cloud data center for Atlassian products, you could consider having a deployment into a European zone, and those kind of things are much easier once you have a nicely packaged up Docker image. So the customer reaction, just a quick aside on what did customers think this week as we talked to them. Well, actually, I've got to say the reaction was pretty good. I expected we'd get a few people saying, no, we can't do it. We didn't actually get anyone who said no to Docker images. We had some people who were not sure. But we even had one person who was really keen, and that was an interesting one because they're using Data Center, and one of the reason they use Data Center is for performance. They have a lot of users, and they found they're having some performance problems with custom fields in particular. Now, by using a Docker image to handle all of our rendering, we're moving a lot of processing time off the data center servers and onto separate servers, which can be scaled separately. And there's potential, and we don't know yet. We've got to test it, but it seems like it's going to be easier for them to scale by having the add-on code running externally. So maybe that could be a benefit for some people and not a negative. So that's it. We're basically, we're trying it out now. We think it's working well, and we've got a lot of interest, so we're considering open sourcing some of the stuff we've been doing in the P2 plugin. So if you're interested in that, come and talk to me, or look us up on the thinktilt.com. We'll be blogging about it over the next few weeks. So if you're thinking about it, have a look at what we write, and we'd love to share some code with you. Thank you.